now we are going to study arc restriking phenomena. Basically, it is very important to understand the arc restriking phenomena. So arc restriking phenomena is, let us assume we have one generator and this is the inductance and this is the capacitance up to the station, means the nearest station, and this is the circuit breaker, this is the circuit breaker, this is the circuit breaker, and since. So what happened when the fault occurs? When the fault occurs, basically the relay senses the fault and gives signal to the trip circuit, and trip circuit open the circuit breaker. When first time the circuit breaker has been open, so what happened? The dielectric stress will be greater than dielectric strength and the arc will produce with the help of electron emission theory, and it will sustain with the help of thermionic emission theory. And we can quench this method by zero crossing detector method or current zero method. So first time when we are quenching the arc, at that time there is a difference, there is a d distance between them, and the primary arc is interrupted. So what will happen, basically the voltage across this contact of circuit breaker VA will be equal to the value of VC. But during this time, during the first arc interruption, what happened? All the current will flow from here. So when this will be open, all the current will be flow from here. So you can see clearly that it will form an oscillating circuit. It will form an oscillating circuit, and when we find the voltage across this capacitor VC will be equal to Vm 1 minus cos of omega t. So VC is equal to Vm 1 minus cos of 1 upon under root L into C into T. This I am not deriving here. So this is the VC. So this VC is oscillating in nature. This VC is oscillating in nature with having the frequency omega n is equal to 1 upon under root LC. It means when we will draw the diagram, it will look like this. So this is, let us assume, VC, and this is omega t. So you guys can see when we will draw this, so at t equal to 0 it will follow like this. So it will follow like this, it will follow like this, it will follow like this. So what is happening exactly? So this distance, this total distance is time period. So this is time is the f is equal to 1 upon 2 pi under root LC. So the total one time period will be equal to 2 pi under root LC. So this will be the half time period, and that is pi under root LC, and this is basically pi under root LC. This distance is pi root LC. So the maximum value of this is 2 Vm. The maximum value of this from this equation is 2 Vm, and minimum value of this is 0 voltage. So maximum value of 2 Vm and 0 voltage. So what happened, basically I am just repeating this. So basically when the primary arc has been interrupted, there is a distance between them. So the voltage VA will be equal to the voltage across the capacitor, and this capacitor voltage is oscillating in nature, having the frequency is equal to omega n is equal to 1 upon under root LC. So having the value of 2 Vm maximum value, what happened when this arc is interrupted, the maximum value of 2 Vm will appear here, and once again the rechecking will done. When again if the dielectric stress is greater than the dielectric strength of the material, then arc will restrike again. So basically arc will strike again. That is why this phenomena is called as restriking phenomena. So this is the whole restriking phenomena, and I'm concentrating here. This 2 Vm is the maximum value, and the maximum value of restriking voltage. Maximum value of restriking voltage is 2 Vm, and to reach that maximum time, that how much time it will take? It will take pi root LC. So this is the diagram. Now I am going to see the relation between VA and IA. So I am drawing once again here. This is, let us assume the axis, this is axis, and this is axis, and now what we are drawing, this is the current diagram, this is the current. After coming the fault, even this will not change its sinusoidal nature. So this is the current, this is a fault current basically, or arc current we can also say. Arc current means the current is going through this capacitor, so this circuit breaker, so IA. And now when during the arcing, we have two conditions. During arcing, let us understand during arcing what is happening. During arcing basically what is happening, there are lots of electrons here. It means there is lot of conductivity here, there is very few amount of resistance here. The resistance during the arcing will be very less, so that Va will be equal to Ia into Ra. If this is very less, so Va will be less, so Va will be very less during this arcing. So during this arcing Va, I am drawing with very less amount, near to zero, near to, it will not be zero, but it will be near to zero. So we will find out, it will happening, arc will restrike again, first. So I'm repeating from start. The primary arc will initiate, and when we will quench this, this will be open circuit. This will be open circuit, and the oscillating voltage across the capacitor will appear across the contact of the circuit breaker, having a 2 Vm maximum value. And once again, the checking will be done with this time when dielectric stress is greater than the dielectric strength of the material, then the arc will restrike. That is why this phenomena is called as arc restriking phenomena. So let us assume we are using our primary interruption, arc interruption at this point. So when we are interrupting arc at this point, zero crossing point, so what will happen? A 2 Vm voltage will generate. I am drawing with the yellow pen. So the 2 Vm voltage will oscillate. 2 Vm voltage will oscillate like this. 2 Vm voltage will oscillate like this, and this time same D has been increasing. So few times later, this D will be much, after becoming the value of 2 Vm across this contact of circuit breaker. Now if D will be much greater, if D will be much, because we know that dielectric stress is Va by D. If D is much greater, whether Va will be very much, due to this D, now dielectric stress will be less than dielectric strength of material, and arc will be removed permanently. So this is the maximum value of 2 Vm, and to reach this maximum 2 Vm value, it will take pi under root LC time.